The videos that you have here allow you to figure out how to go from binary to octal and binary to hex just by using a pen and paper. However, we have the ability to use calculators. Now, this is the calculator for Windows that you can get from the Microsoft Store, and this is the calculator that comes with a Macintosh computer. Now, for both of these, we want to change these to Programmer. So we click here, we can go to View, and go to Programmer, so we have these two versions of the calculator showing that are both in Programmer mode. Let's start with the PC calculator, and you can see if we click on hex here, it has a hex keypad. We click on the decimal, it has decimal. We do octal, it has octal numbers, and if we do binary, it's in binary here. So to enter this binary code, we're just going to punch in 10100110. And you can see already that 246 is what we should have here instead of 146, so we're going to circle this because this is incorrect. But if we look at the hex up here, it's A6, so we're not going to circle this. If we take a look at the Mac calculator, if we click here, this is a hex keypad. If we click here, this is a decimal keypad. If we click here, this is an octal keypad. And if we want to put in this binary number, we just have to go over top of the ones that we want to change. And we click here to change that to a 1. We click here to change this to a 1. We click over here to change this to a 1 and this to a 1. And again, we can see that this should be 246 and not 146. And if we go to hex here, we can see that this is A6, so again, we're not going to circle that. Now in question 1b here, the octal numbers are correct, but the binary and the hex may be incorrect. So let's switch over here to octal, and let's do a clear entry, and we're going to put in 246, 246. So right away, we can see that in binary, it should be 1010, 0110, which it is, and over here it should be A6, so this is indeed correct. Same sort of thing here. If we want, we can go to octal. Again, we can clear and we can put in 246, and we can see that 246, if we go to hex, that's A6, and that is correct. And let's take a look at binary. It should be 10100110, which is indeed correct. Now for number 1C, let's take a look at our second line here. We know that the 6C is correct. So let's clear and make sure we're on hex and type in 6C. Now right away we can see that our octal here is 154, which is correct, and our binary, let's compare this binary to this one, is 0110, which is correct, 11001110, whoops, 1101. So this one we're going to circle because it's incorrect. Let's see how to do this on the Mac calculator. So again, let's clear our display. Let's type in 6C, and let's take a look at octal, which is 154, which it should be, and then in binary it should be 0110, which it is here, 1100, and it's 1101. So in both cases, we're going to know to circle this, and this is indeed correct. Now in question 3a here, we're going to be adding two hex numbers and see if our answer is this. So we've already got it in hex. Again, we're going to clear, and we're going to type AE plus CD, and we're going to say equals. Now the number here is 7b, with a carry, but one of the things you're going to find is because it's not constrained to just showing 8 bits, this 379 is incorrect and this 573 is incorrect as a char number. But again, these bits here, if we ignore this bit here, this number is indeed 7b as shown here. Let's go over to this calculator and do the same thing. Again, we're going to go to hex, we're going to clear AE plus CD, and we're going to hit equals, and we can see that it's 7b with a carry. And again, if we go to decimal this time, 379 is shown here, which is not really correct as an 8-bit number. And octal again, 573, which is not correct. So we just look at the lower 8 bits here, which is 7b again, and this is indeed correct. Doing this subtraction here, again, it's in hex, so let's clear our display here. This is going to be 6a minus fe. Now notice we have all of these extra digits here. And our number here is 6C, and we can ignore all these F's as we'll see later. So 6C is the correct answer. This one here is not correct, so we're going to circle that. Let's validate this over here as well. Let's clear display and take a look at 6A minus FE. And again, we get 6C. So this number here is definitely incorrect, and we should circle it. As far as NZVC, calculators can't help you out with that, so you're going to have to watch the videos that are mentioned here in question 3 to be able to figure that out and be able to figure out which one of these is correct or incorrect. Now the simplest way to do binary subtractions is to convert them to hex. And if we do that, this is going to be 5. 1011 is B. Then we're subtracting from that E, A. And we get is 71 with a bunch of other things here. Now if we do a clear and just punch in 71, then we can see that indeed in binary it should be 0111 0001. Same thing here. If we do 5B, subtract EA, say equals, there's our 71, so if we just clear again and put in 71, then again what we can see here in binary is 71, which is exactly what we've got here. And this is probably the quickest and easiest way to do binary subtractions. It's fairly easy to use one of these calculators to validate which ones are right and wrong in this unsigned chart. So let's continue on to the next question, which is using sign conversions. Now if you remember to convert a negative decimal to hex, what you're going to do is minus 49 plus 256 and then transfer it across the other way. Now minus 49 plus 256 is the same thing as 256 minus 49. And right away what we can see here is CF is indeed the correct number here, CF is validated here, and 317 is validated here. If we do this on the Mac and make sure we're in decimal here, 256 minus 49, and that's going to give us 207. That when we take a look at it in hex, again it's CF here. If we look at it in octal, it's 317, and it shows here as 11001111, same as we've got here. Now to go the other way, if we want to start with a hex value, and these are signed numbers, again we're going to have to clear this. And we're going to, in hex this time, we're going to put in ED. And what we're going to see is ED, hex, binary, and octal are always going to be the same conversion. So let's compare this. 1110, correct. 1011, not correct. Circle this. And our octal number should be 355, which it is not here. So we're going to circle this and circle that. Now let's do it on the Mac. Let's again go to this time hex, put in ED, and we're going to then take a look at it in octal, which is 355, which is again wrong. And again here we can see what it should be here as a number here should be 11101101, which it is not. And for both of these, if we want to figure out what it is in decimal here, we can take ED, which is 237 decimals, so we go to that, and then we can subtract 256, and we get indeed that this is minus 19. Now it's not as easy to do this on the Mac, because if we try that, let's go back here. ED, as we said, in decimal is 237. So if we try subtracting 256, we're not going to find minus 19. We're going to have some other number here. But we did have 237, so we say 256 minus 237. We can indeed come back again with 19, which is a minus 19 here. For question 11b, we have to take this number and make sure this is the binary equivalent. Then we take a look at this number, which is bold, and make sure this is the binary equivalent. Once we've done that, then we're going to take AB and we're going to AND it with 0F, and is that the right answer in hex and binary? Then we're going to take AB and we're going to OR it with 0F, and is that the right answer in hex and binary, and so forth. So let's take a look at doing the third one down here, 4C. So let's start with this calculator here, make sure it's in hex. So we're going to put 4C, and then we're going to AND it with AA. So we're going to go to bitwise, and we're going to use here AA, and we're going to say equals. And we can see that the number here should be 8. So in hex it should be 8, and it's not, it's A. But here in binary it is correct. So we're going to circle this one, but we're not going to circle this. Let's clear again. And this time it's going to be 4C ORed with AA. So we're going to put in 4C, bitwise OR it with AA. And we're going to see EE this time, and as long as this is EE and this is EE, we're okay. Let's clear again. Let's go back now in 4C, and this time we're going to exclusive OR it with AA. And we should get E6, which we're not getting, but this indeed is E6, so we're going to circle this guy here. Now the other one is the NOT. Now it's very easy on the PC calculator to see this, so we're going to start with just the 4C. So we're going to clear. We're going to put in 4C, and we're going to do the NOT of that, because the bitwise NOT is going to be really B3 here, and this is indeed B3, so we're not going to circle those. Now the only real difference here with this one is how to do the knot. So let's do a 4C, and in this case it's called the 1's complement, which is, so we can see we get B3 here and here. So what you have to do with these calculators is go through all of these and make sure that there's none that are wrong, and if they are, you just circle them